Many of our scientists usually conduct our fieldwork during the summer months. In the 2020 fieldwork season though, things were a little bit different. It was a little bit more challenging. It was kind of hard, honestly, to travel anywhere when the whole world was on lockdown. One of our scientists, Jessey Rice, got creative. Like a lot of us during the first few months of the pandemic, he channeled his inner Marie Kondo and looked through Enercan's closet to find things that would spark joy.
My name's Jessey Rice. I'm a research scientist here at Natural Resources Canada. This project that I took on occurred during the global pandemic, so we were unable to go to the field, and I knew that we had all these great samples in our archives, so I thought, what is something that I can do that wouldn't require me to go to the field, so I could go to the archive, look at some of those archived samples, and reanalyzing them using more modern techniques. So the archives are this huge Indiana Jones type building with like a vast area of just rows and rows of pallets and rocks and till samples. They've also got all the original field books from all the old expeditions. So they've got William Logan's original notebooks, some of his old samples. So it's a really cool facility. These samples are from the Keewatin sector, so it's within Nunavut. So it's right within a region that had a large ice divide during the last glaciation. So these samples have been collected over the last 4 decades. What we want to do is to see if we can look at the mineralogy in the very fine fraction of the bedrock. That's why we collected bedrock samples, and see if we can find those same minerals in the till samples that have been transported down ice, and to see if we can get some indicators of dispersal. Another thing that we can use the clay mineralogy is looking at the glacial history of a region as well. So there's regions of static ice, which we call coal-based ice. So the base of the ice isn't moving, so there's no erosion or no transport under that ice. But there's also regions of actively moving ice. We call this warm-based ice, where material is being eroded and transported. So what tends to happen is those regions under the coal-based ice are preserved, and the regions under the warm-based ice have a different chemical signature because there's active erosion and transport. And that's important because if we're collecting a sample, it's important to understand where that sample is being collected from. So if it's from a region of coal-based ice, we know that it hasn't been transported very far in a long time. But if we're collecting a till sample in a region of warm-based ice, we know that that could have been transported quite a ways down ice. So it's really important the context of the glacial landscape, which we collect samples in. So we're hoping to see if the clay mineralogy can help us in determining those different types of environments. So let's say we collect a till sample and we find a piece of copper. Because this is a glacial sediment, we know this was produced by a glacier. So we can look up ice and try to figure out where that copper came from and hopefully find more copper or a copper deposit. So we look at the clay mineralogy of the till and the clay mineralogy of the bedrock and try to match those up and see if we can determine which way the ice has gone, and then we can try to find the likely source of those minerals. To get the size fraction that we need to look at the mineralogy, some of our samples come from bedrock. So we cut a piece of the bedrock, crush it up, sieve out the coarsest fractions, leaving us with the fine clay fraction, and then the SED lab uses the centrifuge to get the very finest fraction. So for till samples, it's basically the same process. However, it's not a hard rock. It's a mixture of sand, silt, clay, and cobbles. So we send that to the SED lab. They sieve out the large cobbles and sand and silt, and then we're left with the clay, and then they use the centrifuge to get the finest fraction of the clays. In the archive, they have hundreds of thousands of samples. And it really puts into perspective all the work that the Geological Survey of Canada has done over the last 180 some odd years. And that's what this project really showcases, is not only does the warehouse, is it a joy to visit, but it also has this amazing world-class collection and a great history, and we can use new modern analytical techniques to do that. So that's what this project focused on.
Luckily for Jessey, we're no longer on lockdown and he has been able to go back in the field. Check out the video on screen right now if you want to see Jessey and his colleagues head to northern Labrador to map the surficial geology impacted by the last ice age.
Make sure to do all the YouTube things, like and subscribe, and keep an eye out for our next video.